Hey, College Trig, back here for this week. This is week 6. There's a test this week. Hours 1 and 3, Thursday, May 7th. Excuse me, from 10 to noon. And then fourth hour, Friday, May 8th, from 10 to noon. It's going to have these topics. We're going to go over basic review right here, okay? Find the magnitude and angle, or and direction of the vector. Okay, so we're going to do a couple of those. We'll start with 3, 3, and we'll do -1 root of 3. The magnitude of a vector is going to be the square root of 3 squared plus 3 squared equals square root of 18, otherwise known as 3 roots of 2. That's the magnitude of the vector. The direction, we set up tangent of theta is equal to b over a, or 1. Tangent's positive in the first quadrant and in the third quadrant. If you inverse 1 on your calculator, you get 45 degrees. If you plot this, it is the first quadrant, not the third quadrant. So therefore, theta is equal to 45 degrees. So you have your magnitude and your angle. This one's slightly different. Square root of -1 squared is 1. Square root of 3 squared is 3. 1 plus 3 is 4. Square root is 2. 2 is the magnitude of that vector. The direction, tangent of theta, is equal to root of 3 over -1, which would be negative root of 3. Tangent is negative in the second and the fourth quadrant, second and fourth. If you were to plot this, you would be in the second quadrant. If you inverse the root of 3 for tangent on your calculator, you get 60 degrees. So that forms a 120 degree angle. 120 degree angle. So magnitude, angle. Okay. We'll try 2 more of those. From -1, 0, and 2, -3. -1, 0, square root of 1 plus 0 is 1. That's the magnitude of that vector. And then tangent of theta is going to be equal to 0 divided by -1, which is 0. Where is tangent equal to 0? Well, tangent is undefined there and there. It is equal to 0 there and there. So the question is it to the left or is it to the right? Well, if you were to graph this, it would go off to the left. So that would be theta is equal to 180 degrees. That's your angle. For this one, we have the square root of a squared plus b squared, root of 13. Okay, now we got the root of 13. Now we find our angle. Tangent of theta is equal to -3 over 2. Tangent is negative in the second and the fourth quadrants. I don't know where tangent's equal to 3 over 2. So I take my calculator, second tangent, or tangent inverse of 3 divided by 2, and I come up with, it says 56.31 degrees. So that means that if this is plotted over 2 and down 3 in the fourth quadrant, I have 56.31 degrees. So I'm going to subtract that off of 360. 360 minus that 56.31, and I get theta is equal to 303.69 degrees. 303.69 degrees. Okay. So the first skill you're going to have to do on your test is to be able to find the angle and the direction of a vector. Okay, I'm sorry, the magnitude and the direction of a vector. The second thing you're going to have to be able to do is to be able to find the product and angle between the vectors. Okay, so we'll do 3 of these. You had, say, 1, 3, and negative 1, 2. The product of the vectors, the way we find product of 2 vectors, multiply that times that, we take the horizontal components, multiply to get negative 1, add it to 3 times 2 is 6, and we get 5. So that's the product. How do we find the angle? Well, we set up cosine of theta is equal to the product divided by the magnitude of this. Let's see, what's the magnitude of 1, 3? 1 squared is 1, 3 squared is 9, so it'll be a square root of 10, times negative 1 squared is 1, 2 squared is 4, that would give 5. So I have cosine of theta is equal to 5 over the root of 50. Now, don't worry about simplifying that, because I know you could simplify the square root of 50. It really doesn't matter, because that's not your final answer. You know, cosine of theta inverse of 5 divided by the root of 50. And I get 45 degrees. 45 degrees. Now, if you were to actually graph that, you know, you'd have over 1 and up 3, back 1 and up 2. You know, does that look like it might be a 45-degree angle? Sure, yeah. You know, you can kind of graph it and see what it looks like a little bit. Try a couple more of those. 0, 4, and 2, 0. So the product would be 0 times 2, which is 0, 4 times 0, which is 0, and I get 0. So that's the product. So we have cosine of theta is equal to 0 over the magnitude of this. 0 squared is 0, 4 squared is 16, square root is 4, times 2 squared is 4, 0 squared is 0. So I have the square root of 4, which is 2. Or 0 divided by that is 0. And maybe you remember something that we talked about orthogonal vectors. If the dot product is 0, then in fact it forms a 90-degree angle. So theta is 90. Or maybe some of you actually looked at these ahead of time and said, well, if I were to graph these, 2, 0 is going to look like 1, 2 like that, and 0, 4 is going to look like 1, 2, 3, 4 is going to look like that. And I can tell that it's going to be a 90-degree angle. So there's ways to justify and verify your answers. We'll try the last one in this situation. Then we'll move on to one more problem. We're going to go negative 4, 1. And then we're going to go 1, negative 4. I want to find the product and the angle. Product, negative 4 times 1 is negative 4. 1 times negative 4 is negative 4, and I get negative 8. Negative 8 is my result for the product. You find the angle, you say cosine of theta is equal to that negative 8 divided by, we need the magnitude of this. Negative 4 squared is 16. 1 squared is 1, that makes 17. So the square root of 17. Same thing here. Square root of 17 times square root of 17 is just 17. So let's go ahead and do cosine inverse. Cosine inverse of 8, actually negative 8 divided by 17. For cosine, when you use cosine, cosine knows the difference between positives and negatives, so therefore go ahead and just include that negative. I get 118.07 degrees. There you have it. Last example is involving work. We know that work is equal to the force times the distance. So if we say that the force vector in this situation is 3I plus 6J, and the distance, we're moving it from point P, which is going to be located at negative 1, 4. And we're going to move it to point Q, which is located at 310. All I need to do is say that work is equal to my force vector, which in this situation is just 3, 6. And then I need my distance vector. I'm moving it from -1 to 3. So 3 minus -1 is 4. I moved it 4 units horizontally. And I moved it from 4 to 10. So 10 minus 4 is 6. I moved it 6 units vertically. So the amount of work done is the dot product of those vectors. Or 3 times 4 is 12, plus 6 times 6 is 36, and I get a grand total then of 48. 48 units of work is being accomplished in applying that force and moving an object from that location to that location. So there's a nice little review. Hopefully this is very straightforward. A brief overview of your use of vectors, and should be able to help you as you move forward in any physics class or anything like that. If you cannot make that 10 o'clock to noon time frame, it's much more manageable for me to be able to have a specific time where you guys are doing your tests as opposed to putting them off whenever. Also helps make sure you're kind of working on them on your own. And so reach out to me if that doesn't work for you. I'm happy to try to work around that, but I do like to do multiple versions of the test then in that situation. So take care. Hope you have a great one.